recorded. Good.
The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS and software test professionals, welcome to our webinar on profiles and failure. This is being broadcast live from STPCon in San Diego, United States, with a live audience. I'm Rex Black. I'm president of RBCS. We are a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has delivered insight and confidence to hundreds of clients around the world. Our team of international consultants deliver customized training, consulting, and outsourcing services to companies who are looking to improve their testing and quality assurance practices. I'm the author of 12 books on software testing, available via our website or on Amazon. We are presenting this webinar in partnership with Software Test Professionals. You can check out their website at www.softwaretestpro.com. That's softwaretestpro.com, all one word. Attendance at today's webinar earns PMI PDUs. I would like to thank Linda Thorne for reviewing the materials for PDU status and for making valuable suggestions. Attendees will receive an email within 5 days of the webinar describing how to claim the PDUs. PDUs are available for live webinar attendance only. If you are here in the live audience and want to get the PDU code, leave me your email address before you leave, and I'll make sure that you get an email to that effect. A couple housekeeping notes. If you have questions during the course of the webinar, submit them at any time via the webinar interface, but please note that I will only be able to look at those at the end. You do not need to ask for copies of the presentation. The presentation is on the web, rbcs-us.com. Navigate to the resource tab in the upper center of that page, and then navigate from there to the basic library, and you will find the webinar slides there. Recorded version of this webinar will be posted on the digital library and also on YouTube within about 5 days. By attending this webinar, you have been automatically registered for the free e-learning drawing. Check your email over the next couple days and watch the spam filter. Again, if you want to be entered and you're in the live audience, just leave me your email on the way out, and we'll put you in the drawing. If you are having problems with getting to the webinar, contact GoToWebinar support. Generally, these problems are either browser incompatibility, company firewalls, or audio settings, so those are usually the right place to start. Hope you enjoy this free webinar from RBCS. We do these as a service to the software testing community because at RBCS we are a not-just-for-profit company. So today's presentation is about studying failed projects to see what lessons we can learn from them. Interesting quote here, a little difficult for those of you in the room to see. I'll try to fix the screen real estate. Quote from Ben Franklin about study of errors being perhaps more valuable than study of success, study of discoveries. And so I certainly have learned a lot from working on projects that failed, and generally the bigger the failure, the more instructional the experience is. So I'm going to present 3 detailed case studies of projects that failed, and then do some analysis on why they failed, what happened, and what could have saved them. For all 3 projects, there are some common themes in what could have prevented their failure. Earlier testing was definitely one of them. Getting into the testing late and being deluged by a large number of defects was a common theme. Ensuring that there was higher quality throughout the project, more attention to detail, more attention to quality by all the participants would have made a huge difference. Collaboration. In every one of these cases, there were collaboration issues, that the stakeholders and other participants did not collaborate effectively with the testers. There was blame on both sides of that relationship. Tighter collaboration between those stakeholders and the testers would have made a big difference. And bad vendors and bad management of the vendors' quality was another big piece in all 3 of these failed projects. So let's take a look. Let's take a quick check and make sure this is all looking okay. Yeah, good. So first project that we're going to look at, this is a banking project. There was a browser-based commercial off-the-shelf or COTS home loan processing package, which I was kind of surprised to find that there would be such a commercial off-the-shelf application. It seems like a niche, but apparently there's a big enough market for those kinds of applications that there was a vendor that made them. And they approached, or actually more correctly, were approached by my future client. Sorry about the timeline thing here, but this will become clear in a minute. They were approached by my future client to provide this application to them. They signed a deal, and the project did not go well. And I was called in, my associates and I were called in after the project had failed to do some analysis of the failure. That's why I called them my future client, because at the time of this project they were not my client. I was called in to analyze the failure of the project and to provide some insights onto how to successfully execute the project the next time around. So the application was written in Java-based application running on a sort of standard three-tier browser-based architecture. So there's a presentation layer, right? Web server, application server, database server. So all the major browsers at that time were supported by this application, but my client in their call center, the telephone bankers used Internet Explorer. Okay, so single browser on a standardized PC platform. Everybody's running Windows, so it's not like the internet application where anybody could be running anything, right? There's a total monoculture here from a hardware perspective, right? Complete standardization of hardware and software, operating systems, browsers, etc. I say that just to point out that this is not, as the cliche goes, rocket science, right? This is a very straightforward kind of project, right, of which thousands succeed every year. Okay, so there's nothing inherently complex in the technology, the project itself, etc., that would have predisposed this project to be problematic. Unlike some of the others, the other two that we're going to look at, which did have technological challenges. Now, the original plan, since this was a commercial off-the-shelf application, was that the application would be delivered for a 6-week period of acceptance testing. Now, there was some discussion of customization, but apparently the expectation on both sides of the relationship, vendor side and my client side, the bank, was that the customizations would be minor and could easily be accommodated in this 6-week period. The seeds of failure were sown in that assumption and compounded by, or if you want to continue the metaphor, watered and fertilized by a statement that the vendor made to my client's project manager, which was, we don't need any requirements. Whatever you guys want, any changes you guys want, we're going to do it for you because you're a really important customer to us. That was a well-intentioned but tragically stupid comment to make, because it was seen as an open invitation to all of the users, the telephone bankers who were involved in the acceptance testing, to start wish listing like crazy in the bug tracking system. So the project went on for 12 weeks, which is not good when you plan a acceptance test period and it doubles in size. And they finally stopped it, fired the testing service provider, which you could cry about the injustice of that, which I'll leave to you, because since we got hired, my company, that's okay by me. we were brought in to try to figure out what the problems were. And in all fairness, it really was not the testing service provider's fault. As I said, the root of the problem, based on what I saw, was that failure to control the scope, right? No agreed upon definition of what done looked like, and then that was compounded by a complete absence of testing and quality management best practices from beginning to end. So let's take a look. I'll show you some pictures here. Let me just quickly check on the status and make sure we don't have any problems here. Nope, that's all looking good. So this is a maybe not a very pretty picture, but it's showing the arrival and resolution rates for defects. Now let me get the spotlight going here. This red line going across the top is the reddish black line, is the cumulative number of defects reported over time. And this green line here is the cumulative number resolved. Okay. So remember, 6 weeks was the original plan, right? So 1 week, 2 weeks, 3 weeks, 4 weeks, 5 weeks, 6 weeks. Are we done yet? No, we're not done yet. 7 weeks. Are we done yet? No, we're not done yet. We're no closer to done than we were last week. 8 weeks, we're not done yet. 9 weeks, we're not done yet. And 11, 12, no closer at the end of the 12th week than we were at the end of the 6th week if you measure closeness in terms of the gap between the number of defects reported and resolved. See that? The gap is basically the same. It's about 50 plus defects pending. Different defects, but defects, right? The key here being that the defect discovery rate is, that curve is not flopping over. What you would want to see is that it would level off towards the end. I mean, what should have happened is somewhere around week 3, this curve should have started to level off, be intercepted by the resolution curve. That's not what happened. Why did that happen? Well, you can guess. These were not so much defects that were being reported as stuff I want for Christmas, and Christmas is now, right? Christmas has come early on this project. I wanted to do this. I wanted to do that. Some of the defect reports that I look at, actually, you would find chains of these reports where it would start off and say, feature X exhibits behavior A. I don't like that. Please change it to be behavior B. And then that would be followed by feature X exhibits behavior B. I thought that would be right, but actually now that I think about it, it should really be C. And then feature X exhibits behavior C. No, darn, that's not quite right either. How about D? And in some cases, that chain would actually end with feature X exhibits behavior W. Now that I think about it, I actually liked it better the way it was. Please change it back to A. There were literally, like that long, like these sequences of 10, 20 defect reports all griping about minor stuff that eventually ended up with a, if you remember the old Saturday Night Live Rosanna skit of a big never mind at the end. Well, okay, change it back. So, what would you expect from the absence of any sort of control? Exactly this kind of behavior, right? One thing I should also add is that the vendor is not charging. They're not charging for the time spent on doing this work. This is a fixed bid contract the vendor has agreed to. Now, the pace at which this work was done was another contributing factor to its ultimate demise. There is such a thing as too fast. There is such a thing as cleaning up a mess too quickly and finding that you actually made a bigger mess in the process of doing that. The way this project worked, the client is on the East Coast, vendor on the West Coast. So there's a 3-hour time difference. So every day at noon, Eastern Time, there would be a bug triage meeting, basically a review meeting where the decision was made about which bugs that had been reported in the previous 24 hours by the testers, who again are on the East Coast, which of those bugs would need to be fixed. That meeting would end around 1:30 Eastern Time, which would be about 10:30 Pacific Time, which, as you know, and when talking internet startups, that's about the time that people start to shuffle into work, right, and consume their first, gallon of coffee. So what would happen is after the bug triage meeting, the program manager on the client side would go for a walk in the, I would call it a cubicle area, but they weren't really cubicles because they were this half-height kind of cubicle, so it was very easy to see people. In other words, the developers couldn't hide. And the program manager would just walk around with a stack of defect reports and hand them out and tell the developers, these must be resolved before you leave today. So the idea there, of course, was that this would result in an acceleration of the pace of fixing problems, that we'd be, quick, and things would get done. The reality, of course, was that this accelerated the rate of mistakes, right? Because people were in a hurry. Everybody's feeling rushed to get done, rushed to get a fix checked in by the end of the day. It's standing between them and their craft brewed beer because this is, after all, Seattle, so, it's a big problem. What you see is that desire to hit that one-day turnaround very quickly runs into the wall of complexity. And so this is the closure period that we're looking at here. The closure period is the average time from discovery to resolution of a defect report. And the rolling closure period is the average for all of the defect reports closed on or before a given day. So what we can see is that very quickly the developers stopped being able to hit that target. They were still being put under tremendous pressure to hit the target, but they were not doing so. Now the average has floated up to about 6-7 days here, as you can see, by the end. And in some cases, considerably longer. So in spite of tremendous management pressure, the defects were not getting fixed in a what was considered to be a timely fashion. They were getting fixed very poorly. More on that in a minute. Let me quickly just check and make sure we're not having any sort of audio or visual problems there. No, that all looks good. GoToWebinar is great, but a little bit of screen real estate issues with it sometimes, especially in a projector mode like this. Now, one of the things that I wanted to look at on this project was maybe, just maybe, the project was actually doomed from the start. And what I mean by that is that, I had been told anecdotes by people on the project about this deluge of defect reports that weren't actually defect reports, they were change requests, right? But I'm always, as those of you who are in my tutorial on Monday know, I'm always a little skeptical of things that people tell me that sound reasonable, because sometimes those things are wrong. And so I want to check, say, it's okay, it sounds reasonable that there were a lot of problems reported that weren't actually problems, but let's see where the problems really were. So I looked at a classification of the defects. Where were they? The user interface, this is the presentation layer running on the web server. And the loan engine, this is the Java code that's running on the application server, and it's the database bits, basically the stored procedures and the schema of the database itself, and so on. Okay, so these are the two pieces of the application that are actually being purchased. This other stuff, the legacy application, the decisioning mainframe, the network, deployment process, middleware, other pieces, these are all the things in the data center that the application had to integrate with. Okay. Now, so when I said doomed from the start, what I meant is it's possible that there were so many system integration test defects, right? Just the app would not live and play well with others in that data center, that maybe it didn't actually matter what changes were made on the application, that it just never would have been made to work, right? But actually, as you can see, only 30% of the defects, some say 200, 250 defects total, were identified in the other areas here. You see that? Most of the defects that were reported against either the user interface, that's the 43%, or the loan engine, that's another 27%. Together, they account for 70% of the defects, right? So now, going back to this chart, we say, all right, well, about 30% of the defects, so yeah, like about 250, say 300 defects were actually essential defects, right? Those integration problems had to be resolved. That's not something that a telephone banker had on their wish list, right? It had to work with the other applications it was going to integrate with. Could those, say, 300 real, honest-to-God essential problems been fixed in the 6-week period? Well, let's see. 1, 2, 3, 4, 5, 6. In the first 6 weeks, 400 defects were fixed. So now, obviously, further analysis would be required to be sure that we're doing an apples-to-apples comparison here, that the size of the effort expended on the 400 defects that were fixed, same as what would have been required to fix the 300 or so essential defects. But, you know, you got a pretty good fuzz factor in there, about 25%. So there's certainly some evidence to suggest that had there been a focus on fixing only the problems that were really problems, that could have been done within that 6-week period. Okay? So this is why I say the project did not have to fail, and why I put most of the blame for the project's failure on that absence of scope control, right? That is not managing the vendor properly, not managing scope, really is the main thing here. Now, some of you have seen this before. It's been in one of my other presentations, but this had to do with the analysis of how many defects were reported more than once. And the way this works, the defect tracking system that the company used had a feature where it would count the number of times the defect report was opened. So if the report was opened and it was fixed by a developer, and then we ran a confirmation test, the testers ran a confirmation test against it, and the problem was actually fixed, they close the report, and you never see the problem again, the defect count will be 1. That's what you would want. In other words, that the confirmation test passes the first time and the problem is never seen another time. Now, if the defect report fails the confirmation test, in other words, the fix does not actually fix the problem, the report is reopened, which then increments the opened count, increasing it from 1 to 2 or from 2 to 3, etc. So that's how the open count goes up. Another way it can go up is if the report is closed, the confirmation test originally passes, but then subsequently the problem is seen again, then the report is again reopened, and that would also increment the open count. Okay? So what we see here is really the consequence of the attempt to push the developers too fast. As I mentioned in the metrics discussion, you can see here, fully 1 out of 6, 17% of the reports were dealt with more than once, right? And if you assume that there's about 1 person-hour of waste associated with the failure of a confirmation test and the need for the developer to try to fix the defect again, and you do the math here, you come to a little over 200 person-hours of wasted time, which, you know, that's over 5 person weeks of waste on a project that was scheduled to last 6 weeks. That's significant. That's the loss of 1 full person from that original schedule. And this was not a large project. So, you know, there's a pretty significant drain here. So this, of course, compounds the problem already because of the way that the things were set up. They had created a situation where they were basically asking for more work than they could handle, the vendor was. And then they put in place a defect management process at their end. It included tremendous pressure on the developers to fix immediately, even if they needed some time to figure out the nature of the problem, which compounded the issue because it going faster made things go slower, as it often does. As the reason why cliches are cliches is because they have an element of truth, and the cliche more haste, less speed certainly applies here. There's a lot of hasty work done, which then created problems. So what could have been done to salvage this project? What can we learn from this failure? Better quality throughout the project, right? Better bug management, a more realistic bug fix process. Those things would have been essential, particularly had they done a good job of defining what constituted a defect versus what was a change request, right? Which to me, that's part of bug management as well. It's just differentiating between things that are in scope and things that are not. That didn't happen. Collaboration between the testers and other stakeholders was missing. As you can see, the testing service provider, which organized and managed the user acceptance test, was scapegoated for the failure and fired. The users themselves, who were doing the actual testing, were pretty much just making up requirements as they went along. And the testing service provider did not work effectively with others in the project to try to put any controls in place on that. Any telephone banker could file any report that they wanted to, and there was no sort of filter there. And then the vendor quality management was very poor. There was a tremendous amount of distrust between the bank, the testing service provider, and the software vendor. By the end of that relationship, it was just completely poisonous. They were, you know, at each other's throats, blaming each other. This was compounded by the fact that there was a bank merger that happened, and the stakeholders were on the telephone banker side, and the people who were running the project, the stakeholders on the telephone banker side were on one side of the merger, and the people running the project were on the other side of the merger, and their company cultures were completely different. So the people running the project were very entrepreneurial, I guess you would say, aggressive, and the people on the telephone banker side were very risk averse. And so it then just made the relationships all that much worse, because the judgment, the telephone bankers and their managers, was these crazy people are trying to stick us with this application that isn't going to work, and it's going to create all sorts of problems for us. So by the end, the people doing the user acceptance testing were actually wanting the project to fail. They were what I sometimes refer to as anti-stakeholders. Right? They have to be involved in the project, but unfortunately their interests are best served by the failure of the project. So, and they actually weren't the only anti-stakeholders. So millions of dollars wasted ultimately. The second go-round was no more successful than the first, because there was really there needed to be fundamental changes to address these issues, and they were not made. A lot of ill will, dozens of person-years of effort wasted. So these things happen, but it is an unfortunate situation. All right, so next project here, Project B. Keeping these anonymous to avoid embarrassing anybody. This project was an insurance project. Our client, which was a large bank in Australasia, had, through acquisitions and over the course of time, accumulated a number of legacy insurance product lines. Well, they would buy a bank, and that bank would also offer life insurance, and so there's that set of policies, and that's managed in a separate system, and then there's this other one and this other set of policies in another system, and so forth. So there were quite a few of these different life insurance policies that were floating around out there, each one having its own separate application that was used to manage it. Because after all, at the time, there were separate groups, right? So each group, each bank, built its own application to manage the policies. And when the mergers happened, when the bigger bank bought the smaller bank, rather than immediately figuring out how to digest the different applications and merge them in, they just kept them. And so they had gotten themselves into this place where they had many different applications being used to run similar but not identical life insurance policies. They did some analysis and realized that sucks. We are wasting a huge amount of effort on this. This is very inefficient. We need to rationalize these. We need to get a single maintainable system that manages all of our different policies. Now, obviously, they couldn't change the policies, right? And the policies themselves had been sold to people, and the policies had particular features. So the application had to be designed in such a way as to be able to handle all the different policies that were out there. They recognized that this was going to be a very large project, so it was planned for 5 years, and there were a sequence of major phases, phase 1, 2, 3, 4, etc. And then what happened is that they further broke down the phases into sub-phases, so there was like 1A, 1B, 2A, 2B, and so forth. So I got called in towards the end of phase 3B. That's about 3 years on at this point. Was told, look, we're having some significant problems with this project. We'd like you to come and take a look at it, tell us what we could do from a testing and quality point of view to get back on track and ultimately have a successful conclusion. So I did an assessment, and what I found is not unusual when I get called in to do an assessment on a troubled project where they say that the testing is the problem. It turned out that the testing really was not the problem. The defect detection effectiveness of the system test and the user acceptance tests was 95 to 98%. This is calculated by looking at the number of latent defects that were discovered in subsequent phases but had been introduced in previous phases. Obviously, we didn't have true production failures, but we could look at what was found in phase 3B that had actually been introduced in phase 3A or before and say, oh, look at that, that's an escape. Design specifications and use cases were used as the test basis, and 100% coverage was achieved. They had traceability of the tests back to the specification elements, full coverage there. The return on investment for the testing and the effort saved from our analysis was 1,300%. So in other words, for every dollar spent on testing, it was saving about $13 in avoidable what would ultimately be production failure costs. So, not a problem on the system test or user acceptance test side. Not surprised by that. Now, the software development lifecycle was described by a number of participants as agile. I heard the word agile used a lot, but then if you looked at it, it really wasn't agile. Particularly in the sense of the unit testing. There was very sporadic unit testing. Some developers did a reasonably good job of it, but for the most part, it was something that didn't get done well, or in some cases not even at all. And basically, once things started to go badly in the beginning of phase 3, there really wasn't any life cycle. It was just, here's a bunch of problems, let's just react to them. It got very, very chaotic. Now, the test team had identified two of the major problems here, that there basically was very little unit testing going on. So a lot of defects were being delivered to them that really should have been removed earlier. Plus, there was a total breakdown in design. The two people who had appointed themselves the chief architects of this project, their primary qualification for that role was that they had no degree or any other qualifications as software engineers. They had their qualification was that they had set up the Access database that had been used as the foundation of one of the applications that was being replaced. Access database, Microsoft Access database, running on a small Windows server. Okay. This was their knowledge. I tried to engage one of them in a conversation about normalization and denormalization of databases, just to get a sense of where their head was on that, and I got the same kind of look that I would get if I had that conversation with one of my dogs. There was a total absence of comprehension. In fact, actually, my dogs would have engaged more, because when I talk to my dogs, they're always sure I'm saying something interesting. They just don't understand. It often has to do with food, so they are engaged. These guys just looked nonplussed and irked that I was actually trying to have a conversation with them, because after all, I was only a tester and they were designers, as they referred to themselves. So to the extent that the test team was trying to say, look, we really need to revisit the database design, these two fellows were saying, well, you have no qualifications to question our design work. Now, it wasn't just the testers. It was also the database administrators who were working on the project who had pointed out to me that the database design was a complete disaster. It wasn't that it had once been normal and then had been denormalized for performance sake. It had never been normal, and it just started off life denormalized and got less normalized as time went on. There were queries that were doing many-to-many joins across tables that were going to have hundreds of thousands of entries in them. And they just had no, when you said that's not going to scale, these people had no comprehension that there was going to be a problem. There were very few code reviews. To the extent that they did happen, they were very ineffective at finding problems. The test team had put together a very realistic estimate of how long test execution would actually take, which was greeted by the stakeholders saying, oh no, we can't possibly give you that long. It's going to have to be done in half of that time. And so they tried to get it done half of the time, and of course it didn't get done, so it had actually slipped out to have consumed all the time they originally estimated. Specifications were very poor, so what happened was a lot of the bug reports were written as an attempt to try to clarify ambiguities or lack of information in the use cases in the design documents. Test cases would basically have question marks for what the expected results were at some places, and the testers were told, well, you're just going to have to report that as a defect when you get there, and we're going to have to use the defect management process to try to resolve that issue, which is horribly inefficient, and obviously creates huge obstacles for the any sort of timely resolution project. Now, there's a bigger problem going on with the bugs, and we drilled down. What we found was there were 4 particular subsystems that were the main source of problems. The number of bugs was not unusual. I did a benchmarking of the number of bugs based on industry average, and it was not an unusual number of bugs, but the bug clustering problem was extreme. There were, in these 4 subsystems, just incredibly complex design problems related to the ability to respond in a timely fashion. As I said, you had these many-to-many joins happening across these large tables that were just inherently very slow and could only be resolved by a complete redesign of the database, which nobody was willing to undertake because at that point they felt they were way too wrapped around the axle, as it were, on the database design, and that changing the underlying design would have forced a rethink of all of the queries, which would have percolated up through the entire application and brought them to a dead stop. My point at that instance was, well, you're already at a dead stop, and in fact what you're going to do at this point is be continuing to go backwards. If you continue to work on this design, you should just rip it up and start over, but I didn't like that idea. There were a lot of data quality issues, so they were trying to import into this database data from the other policy repositories, which of course they had to do, but what they were finding was that they hadn't made any provisions for the kind of noisiness that was in the other repositories. They just assumed, oh, the data in these other repositories is pristine. Well, that's never true, because I've read multiple studies where, on average, production data, you have 25% of the records have some sort of problem with them. Might not be a very serious problem, but there's something wrong with it, some sort of data quality issue. No provision had been made for that in the plan, and this was starting to really create problems for them because they were finding that they could not load data from some of these legacy systems that they had without changing the database, which again they thought they could not do. And then there was legacy code floating around that had a lot of maintainability issues that nobody wanted to tackle. And as I said, the bad database design was one of the main roots of the problem here. Until that was going to be tackled, there was very little hope of getting anything fixed. This is showing the closure period and the way that the closure period is progressing as the project went on. As you can see, that over a fairly short period of time, taking the 12th of each month as kind of the checkpoint, the closure period degraded. Closure period degraded from just a few days up to close to 50 days. So let me check and make sure that didn't hose anybody up there. No, okay, good. All right, and then this is the bug clustering, and as you can see, half of the bugs, there are about 100 areas that have half of the bugs, and then 100 subsystems, if you will, and then you have 4 particular subsystems where that's where the bugs live, right? So you notice that Loans has 79 bugs in it, and there were 100 categories that had less than 70 each. So this is clearly where the problems lived. And this stuff, as I said, a lot of it traced down into the database design. So what happened? Well, again, this presentation is called Profiles and Failures, so you can imagine that the end result was not good. The project was canceled prior to trying to undertake Phase 4. Again, had there been earlier testing, had the unit testing and better testing in earlier phases pointed out the intractable nature of the database design, then they probably could have tackled it then, or better yet, they could have focused on quality throughout, done careful reviews, done some performance simulation, get those fatal design bugs, database design bugs out of the way before they even started testing. A sort of poison chalice situation had been set up here from the way that the vendor management worked. They they put out the request for a proposal to 3 different vendors, and I got a chance to review the responses from each of the 3 vendors. So most of the selection process was based on cost and schedule, right? The 3 vendors were each judged by whatever criteria, I couldn't quite get a line on what, to be equally qualified to do the project. So they said, well, whoever is the cheapest and the fastest gets to do the development work. Then they said, whoever is the second cheapest and fastest gets to do the testing work. The second prize is doing the testing. Okay, so what's the interest of the testing service provider? To basically undermine the reputation of the development team in the hopes that the project will be checkpointed midway and somehow put out to bid again, and they can win the more lucrative development work. And that clearly showed there was absolutely no sense from the testing service provider side that they were filled with anything but glee over the fact that this project was crashing and burning, and that they could clearly point their finger at their competitor. They were going to have a great case study in why their other potential customers should never hire those morons again. They were thrilled. The developers, on the developer side, they were chagrined and looking for ways to try to blame the client. The losing proposal, which I read, actually was the most realistic of all of them and would have succeeded, because it started with throwing out the existing applications entirely in terms of their implementation and only studying the capabilities that they provided. So that flawed access database schema that ended up living on in the new version of the application would have been thrown out. So 150 person years of effort lost on this one. That's a lot of time, millions of dollars, and of course there's a tremendous opportunity cost associated with that too, because you can think of all the other things the bank could have been doing while they were squandering time and money on this failed application. And note that the end result was that there was no change. I mean, they were still stuck with the legacy application, so they were exactly where they were when they started. No better off. Now, of course, the 2 vendors were materially better off. They had the money. The test vendor, testing service provider, came away from it looking, I suppose, reasonably good. I think actually looking better than they probably should have because of their absence of collaboration with their competitor. The development vendor came out looking appropriately bad in the circumstance. Okay, so number 3, project 3. This is a entertainment company. They were creating a system of systems that was centered on a Unix-based international network of interactive voice response servers tied to some fairly sophisticated call centers with skills-based call routing and so forth. I say an entertainment company here. They were actually a dating service, which made for a very amusing interview process when I went up there to talk to them about managing the testing for this particular project. They wanted to make sure I had the stomach for it, so they played me some of the recorded advertisements off of this IVR system, some of which were rather salty, I would say, but it was an interesting way to spend 18 months working on this project. The underlying technology was very interesting, and for that time, this is about 10 years ago, pretty cutting-edge stuff. High-density IVR servers distributed and tied together through this wide area network across North America that was going to tie into these call centers. 7 major systems and the overall system of systems. So this project was way too big for the client to do themselves. So what they did was that they organized a collection of subcontractors to do the development, and of course we're doing the testing for them. And the developers, these vendors, vendor management was definitely an issue, as you'll see. They were responsible for the code reviews, the unit testing, the unit integration test, and the component testing of the stuff they were building. And then they would hand it over to us. We were responsible for what was called pre-integration test, which was taking the components as they were coming together and trying to make sure that they could talk to each other so that we wouldn't go into system integration test and find out, oh no, nothing works. This was the idea. And then we were responsible for system testing each of the systems once they were finished independently to make sure they worked on their own, and then system integration testing everything together. And again, the objective of the system pre-integration test was to try to get most of the integration risk off the table before we got into system integration test, because we had a pretty aggressive schedule for the system integration test. We wanted to finish it in about 6 weeks. And so in order to accomplish that, I sat down and put together what I thought was a fairly well considered pre-integration plan. What we had was a sequence of 6 test periods called Backbone 0, Backbone 1, etc., through Backbone 5. And here are the major systems included in the system of systems. And A and B, this is the hardware and the network, so this is sort of the environment in which things live, so this just has to do with what version of the hardware and network we're testing in. These guys here, these are the actual software applications, and so for example, C1E1 means the IVR application sending information to the data center through interface 1 of the IVR application to interface 1 of the call center application. They used a publish-subscribe mechanism to define different interfaces that would allow data to be sent back and forth. So from IVR to call center, and then from call center to IVR. That's what the E1C1 means. Okay? E1G1 means sending data from the call center to the content management system, and G1E1 means sending data from the content management system to the call center. Okay? So you see the plan here that we're going to try to test these interfaces as they become available to us. Time is moving along this way. This is the last 2-week period of the pre-integration test, this being the first. I had asked that, if you look at this table, you see that a lot of interfaces are being added later. I had asked that we try to shift this stuff earlier, but the developers said, no way, we just can't have it done. This is the earliest we can get it to you. One other thing to know about this is that the tests were automated. So we're using automated tools to drive data through these interfaces, and the tests were cumulative. So in other words, in B1, we would repeat all of the tests that had been run in BB0. BB2 here included all of the tests that had been run in BB0 and BB1. Right? So there's a cumulative accumulation of the tests to be run here. So that looks good, right? But what ultimately happened? So pre-integration testing was supposed to start on July 15th, but unfortunately very few of the touch points that were identified in the previous slide were actually available to test. Here, October-ish, we officially started system test, violating the entry criteria of every single one of the systems because the systems were incomplete. We were on a waterfall methodology for the system testing and the system integration testing, so we're supposed to be feature complete, but we started and we weren't. So, you know, what you see here is a fairly low rate of bug discovery, which everybody on the project took as good news, in spite of the fact that I was saying, but guys, we're not testing anything yet. We haven't gotten anything to test. We're poking around the edges, and we're already finding, you know, 100 problems. Come mid-November, we actually started to get stuff coming together, and as you can see, an explosion of bugs. We did have a Christmas holiday. System integration actually started. It was 2 months late. Systems were still incomplete, but even so, there was enough there that we could start finding bugs. And this is the point where things sort of fell apart, right? And shortly after this point in April, the project was put to bed. Taken out of its misery, I guess you could say. Yeah, you can see that it was inevitable, right? The project is pretty much, project was a walking dead man as soon as this point was reached. There were already pretty much irretrievable design problems that had been pushed out, and that's what we were finding. Most of the problems, if you look at the breakdown here of the affected subsystems, you see that most of the problems lived in the interactive voice response application, the customer service application. That's those two components themselves accounted for almost 80% of the problems. The other systems accounted for very few of the problems. So what could have been done here? Well, definitely if the vendors had done a better job of testing things and delivered fewer defects to us, you know, we would have been much better off, obviously. If the planned pre-integration testing had actually happened, that was sort of a last chance to try to salvage this, but it didn't happen. There were design problems, there were code review problems, all sorts of programming issues. Relationships between us and the other stakeholders was not good. There was a lot of siloing. As I said, the pre-integration testing really didn't happen. That should have forced collaboration, but by that time the project was already in way too much trouble. And there basically was very little vendor quality management. The IVR software vendor was absolutely the worst. They refused to take any direction whatsoever from anyone with respect to quality and testing. That with the result that when the IVR application got into the system test and the system integration test, we found huge numbers of problems, most of which could have been found and removed during unit testing if it had been done properly, but it was not. So 100 person-years of waste, millions of dollars, almost sunk the business because this was their core application. They ended up reinventing themselves because they were in some sense, in some weird way, saved by the internet. What they were able to do was say, well, you know, maybe doing this stuff on an IVR is really kind of old school. Maybe we should actually go to using a browser-based approach for this. And they were able to kind of pull some of the fat out of the fire by doing that. But it was a near-death experience for the company. And obviously they would have preferred to have spent all of that effort and money on something else. So there you see 3 projects where improper testing and bad quality assurance practices created problems that could have been avoided if there had been earlier testing, if there had been a focus on better quality from the beginning of the project. The testers had worked more effectively with the other stakeholders. Could have been a focus on finding and removing problems earlier. And the vendors. The vendors had been kept under closer watch with respect to the quality of their work, then things would have turned out much differently in all cases. So, very expensive, each of those. Also, as you can imagine, there's some career issues. I mean, these were projects that lasted some time, and people put a lot of personal energy and time into them. You know, there's a line out of one of Tom DeMarco's books about, I forget which one it was Slack or something like that, where two project managers are having a conversation about projects that they'd worked on and challenging projects, and like comparing notes on the number of people who got divorced because of them. You know, I mean, these were the kinds of projects that really did take that sort of drain on people. So, you know, it's dollars and cents and opportunity costs, but there's also personal issues associated with it. I mean, it's very depressing to put in all that time on something that ultimately fails. So hopefully this has given you some ideas on how to learn from some of these failures. I'll go ahead and put the advertisement up here and get the question and answer panel undocked. Let's put this into normal mode. I'm going to let the folks in the room here ask the first questions. I'll repeat them because I'm pretty sure that you guys out there on the internet can't hear them. So any questions in the room? Yeah, please.
You mentioned an ROI calculation. What's the test behind that?
Yeah. How does the ROI calculation work? It's done via cost of quality. And if you go out to our website, and it's either on the basic library where the webinar slides are, or it's on the articles page. Can't remember which, but you'll find an article that has in it something about analyzing ROI of testing or something like that. If you look for that title, something about ROI, it'll show you how to do a cost quality analysis. Also, there is a spreadsheet that's, I think it's in the basic library, but it might be in the digital library, that'll do cost quality calculations for you. Basically implements the model that's described in that article. So download it, take a look at it. It's pretty self-explanatory. Cost quality is not a particularly complicated thing. The spreadsheet's very simple. There's nothing in there but addition, subtraction, division, and multiplication. So yeah, no second order differential equations or anything like that. Other questions in the room? No? Okay, why don't I go to the questions online, and if other questions do come up in the room, I'll be happy to take them. So I got a question from Eric. How can test teams help improve unit testing processes without having access to source other than verbally influencing development leadership? Well, yeah, that's pretty much it, Eric. I mean, either we as test professionals are able to make a strong business case for better unit testing up front to put that influence on the project stakeholders, or we have to have the technical ability to get involved directly and contribute to the unit testing ourselves. Generally, it's going to be better to try to influence, though. In agile teams, you see that testers do get a chance to get involved, and then, of course, that has some skills implications. We have to make sure we have the right skills. We have a question from, or a comment from Erline. Listening to these mistakes makes me feel better with our enterprise testing standards. Thanks for these reminders of lessons learned. Well, it wasn't actually my intent to provide a good Lord, at least we're not doing that moment. But I can see how that would happen. Yes, some of these practices obviously were pretty bad, and I did deliberately pick out of the many projects that I've worked on and consulted with over my career, ones that were exceptionally bad and that had particularly pointed lessons to learn from them. But I think what you'll see is that even though those same kinds of problems don't always cause the same impact or level of impact as was the case in these projects, particularly the last two, there are always good things to keep in mind. Oh, Michael says, having actually been part of Project C, at what point were you fairly certain the project would fail? Oh, okay, interesting, Michael. You send me an email offline and let's talk a little bit more about where you were on this. Since I didn't say what Project C was, I'm not sure how you know that you were on it, but maybe you remember me from it. At what point was I fairly certain the project would fail? Well, let's see. That my dread, my stomach knots started and continued without let up, only intensifying after a meeting that we had with the vendor on the IVR software side that was saying, well, we've run out of time and we haven't finished our unit testing and we haven't finished our performance testing, but it'll be okay because we're sure everything's going to work. And I think that was like, if I'm remembering it right, it was like September-ish because it was still fairly pleasant weather. And I remember going out of that meeting and saying to the two project managers that the results of that meeting were absolutely the worst thing. It was what I had feared most from that meeting when we sat down to review what we were reviewing with them. And I remember one of the people involved commenting, "Oh, I'm not worried. We're going to catch a break during system test." And I think the graph that I showed proved that we did not catch any breaks during system test. We caught the horse's hoof in the teeth is what we caught. Brad asks, what is the point that you have suggested to kill the project? How can one measure whether the project is failing? Well, I mean, the thing is that Tom DeMarco has this interesting quote about, how does a project get to be late one day at a time? And it's the same thing of how does a project die? It's usually one day at a time. It's death by degree, not a matter of, all of a sudden. I mean, certainly there are some projects where that happens for, some catastrophic occurs and kills the project. But for the most part, it's a day-by-day thing. So, you really have to look at at what point does it become irretrievable. I think part of the problem is that people get personally invested in these projects and are really unwilling to let go of them and say, this is dead, this is done, we need to just kill this and move on. Of all of the clients that I've worked with, I can only think of one, which was Dell Computer, that had a really good mechanism for analyzing the opportunity costs and the projected ROI associated with continuing a project, and they would do that periodically. And when it got to the point where the project was going to be unable to justify the cost from an opportunity cost point of view as well as an actual measurable cost, they would kill it. Other than that, I think it's all most of our clients just kind of do this by gut. Of course, they hope to never get there, so there's sort of a superstition that if we plan for how to analyze when and why to kill a project, then that increases the likelihood we'll have to kill it. I think the reality is the other way around, that if you recognize the things that will kill a project and you know how you're going to spot a project that's on the verge of dying, then you'd be much more likely to avoid it. Let's get up here. Comment from Michael. I don't have a question, but I want to say that I recently purchased Critical Testing Processes. It's an excellent book, and I'm enjoying it quite a bit. Thank you. You're quite welcome, Michael. I'm glad you do enjoy it. As I said, send me an email. Let me know how we were connected on Project C and what you think Project C is. I have a number of emails here from people about, please send me the PMP PDUs. You will receive an attendee email in the next 5 days. And if you have not received it in 5 days, please send an email to info@rbcs-us.com. For those of you in the room, again, you'll need to let me know that you were here, and we can get it to you that way. Scott asks, trying to understand the open count breakdown, would it be fair to call it a reopen count? Let me go back to that slide. It is actually not a reopen count. It is an open count. And the reason for that is that the first time here, it's opened once. Here, it's opened twice. Once when it was originally opened, and then once when it was reopened. And then here, it's been opened 3 times, once when it was opened, and then twice more when it was reopened. So that's why it's called the opened count. I realize that's a little confusing, but notice if I called it the reopened count, then the first column on the left side of the histogram would have had to have been 0. Let's see. So now a question from Gene here. Is most of this project failure, in your opinion, based upon poor communication and or poor planning, or both? Oh, boy. Well, there was certainly absolutely no sense of good communication in these situations. Well, so in some cases, it started out okay and broke down over time, right? So on Project C, for example, we, the testers, really had pretty good communications going with most of the stakeholders until you get into like mid-November, and all of a sudden it's just like all of these defects are coming up. And then what happened was really sort of the classic shoot the messenger thing. But some of the vendors on that project were very resistant to any input from us, and we were saying, look, guys, you're going to have to do better testing before you give us this stuff. You can't throw this stuff over the wall, because once we get there, it's going to be too late. So there's a lot of poor communication that went on. I think in all 3 of those projects, by the time things really were in the final stages of breakdown, there was a tremendous amount of rancor and distrust. Was there poor planning? Absolutely. There was plenty of poor planning, and then there was also good planning that was later thrown out in a mistaken belief that by dropping some of the things that had been planned, it would somehow accelerate the project. For example, we, the test team on Project C, put a tremendous amount of time and effort into planning and building out the capability to do a reliability test for the IVR servers, which was canceled literally the day before the test was supposed to start, just because somebody said, well, we think we could use that server better somewhere else. This in spite of the fact that the business stakeholders have been saying, hey, reliability is a critical quality risk for those servers. You better make sure that they're going to stay up. And we targeted a mean time between failure of at least a year. So there was a lot of just sort of breakdown into chaos that happened, which I guess could be called poor planning in the sense that the planning was done, but then it was not executed. Gene's follow-on comment here, is RBCS a group of fixers? It seems as though you get involved often when projects are in a downward spiral. Well, I mean, that's one of the things that we do is we do consulting work and go in and sometimes try to help clients pull the bacon out of the fire, as the saying goes. And it's an enjoyable thing to do. And as I said at the outset, I learned a lot from looking at projects that have failed. Mary says, testing always seems to be testing things that don't exist yet. Why aren't the test sets designed to test the development that has been deployed? Isn't testing only what is available a more honest assessment of the project progress? The approach used does make for some nice testing metrics. Testing metrics for a custom approach are less clear. I guess, Mary, I'm a little lost here, but was there ambiguity in all of these cases over what was being built and how it should be tested? Yeah, absolutely there was. There was quite a bit of it. you know, it was a failure to commit, and there was committing and decommitting that also happened. So, you know, all of these things were causes of problems. The metrics that I've been showing you are really primarily things that I did in an analytical sense of going in and trying to tease apart what was going on in the projects, with the exception of Project C, where those were part of sort of the standard testing dashboards I was looking at. Dottie asks, have you seen projects that should have been killed but they went ahead to production anyway? Oh yeah, that's I've seen that. Stuff gets put into production and then it's just a walking disaster. We have one client where we went in and that was really sort of the standard thing. And when they put something into production, they would have what I think they called it a crash team, which is like basically the most senior technical people that have been involved in the project, that were actually in their offices 24 hours a day. So they would identify people, and they work 12-hour shifts, and basically there'd be somebody there during the entire day and then somebody there the entire night, and there's a whole bunch of these people in a room. And this was standard operating procedure for the first at least week anytime they put anything into production, because their expectation was they put it in production and it would just be a disaster, and they would spend that first week at least cleaning it up, and then often it was more than a week. So clearly that was a case where they were literally planning to fail in a sense. Fiona comments, you told us your company was involved in Project C in the testing piece. Yes, that is true. I did say that. We were involved in the testing there. I'm getting a number of emails again about PDUs. Please wait 5 days and you will get an email that says this is how to claim your PDUs. If you do not in 5 days, please contact us about that. Please wait 5 days, because it does sometimes take a while for the email to show up. And please do check your spam filters. Those get lost. Brad comments, these are excellent examples of failure. Have you seen projects recover from similar situations? If so, what was the turning point? Unfortunately, I think for any of the projects that had reached the points that were illustrated in these 3 case studies, they were, by the time the intervention happened, effectively already dead. Short of just say throwing things out and starting over, which is really not recovery in any meaningful sense, the projects were toast. Now, obviously, I've got a limited sample size. I only get called in on certain projects. You have to be at a certain level of despair to call in a consultant to try to clean up a failed project. So, are there projects that are teetering on the knife edge of failure and that manage to straighten themselves out and get fixed? I'm sure there are. I don't necessarily get called in to see those. Yeah, question from the audience here?
I've got a question finally. You said that that's a pretty old example of projects. How do you do it here? So modern technology is if the projects will be done today, for example, then would it influence somehow on the investment of those projects?
So does the age of the projects that I'm talking about and would changes in technology have influenced the outcomes? Well, all of these projects are within the last 10 years or so, 10 to 15 years. The most recent is the banking and insurance project, which was within about the last 7 or so years. I don't. It's hard to say. I mean, this is like speculating on would technology X or methodology Y have been a solution in those situations. I don't think so. I think that the underlying problems were much more fundamental than the underlying technology or the life cycle. For example, I think some people would probably say, well, could an agile approach have worked on one or more of these projects? Well, notice the Agile approach really wouldn't have been applicable to Project A because it was commercial off-the-shelf software. So, there really wasn't anything to be developed. And one of the problems was the fact that they got into this sort of semi-agile-ish kind of mode and started just adding stuff to it and changing what it was supposed to do. For Project B, they claimed that they were following Agile, and what happened was they completely lost their discipline in the face of problems, and things totally fell apart, right? Project C, it could have been for some of the stuff, but even so, I mean, if switching to Agile in Project C had meant that when we started getting stuff for pre-integration testing, it was actually ready and worked, and once we got systems for system testing, and that stuff actually worked, then I guess you could say that had Agile methodologies actually been followed on Project C, such that when we got things for the final stages of testing, and when we tried to get involved early, things actually worked, then yeah, I think you could say that would have perhaps changed it there. But it would have required the discipline to stick with it, and that there's no evidence that they would have had such discipline because they didn't stick with the waterfall methodology either, right? We were following officially a waterfall methodology, and there were rules about unit testing and rules about what kind of component integration testing they were supposed to do and so forth. And a couple of the vendors just completely blew that stuff off and said, we're not going to bother with that at all. We're just going to let the independent test team deal with all this. So that's a discipline issue. It's not so much a life cycle thing. If they're not following the rules of one life cycle, there's really no reason to think they would have followed the rules of another, right? And then I think, I could go through the same kind of analysis with respect to the technologies. I can't really think of anything that where the underlying issues were primitiveness of the technology that created the problem. It really was more about, as these things almost always are, it was about the people and the way people either worked together or didn't work together, and about the amount of discipline that people brought to the work and the testing and quality assurance. So. Let's see. So we got a question here from Gene. What prompts organizations to contact RBCS to get involved in failing projects? Well, I guess somebody is familiar with our work and thinks that we could come take a look at what they're doing and maybe propose some fixes and help get them out of the ditch, or at least recognize that the project has failed. And so we'll get an email, and some of these emails are very direct in terms of what they're looking for us to do, and some of the emails are a little more elliptical depending on how concerned people are and where things are. But it's easy enough. Send an email or give us a call, and happy to talk about it. These things are not, these assessments, by the way, are not necessarily particularly expensive. For Project B, the insurance project, I think I was in Australasia for I think 2 weeks, 2 weeks on site, and then there was about a 2-week period where I was writing up the report and collaborating with people on the report. Question from John. On the project that you mentioned that was following an Agile approach, what were they not doing that was material? So that would be Project B again, and I mean, what were they doing by the end is be the better question. It's pretty much none of it. I mean, the sprint discipline broke down. The unit testing completely broke down. They were originally talking about doing pair programming, but that all broke down, and there were no code reviews other than the pair programming. Sustainable workload was completely out the window. People were working 60, 70-hour weeks. The whole thing about, not over-documenting, but at the same time providing sufficient information had been completely ditched. There was basically no information being provided to the testers or to anybody else, so you couldn't figure out what was going on. So they had taken that Agile principle of lightweight documentation to mean no documentation effectively. So it had degraded into a complete reactive hash at that point, and there really, other than people talking about Agile, there really was no life cycle involved or being followed. So, that gets to the point that I was making a minute ago about discipline, right? Whatever life cycle you might follow, to me, it's less important. Life cycles they're a set of organizing principles that should help you organize the project, and different contexts have different degrees of fitness for one life cycle versus the other. But if you don't have the discipline in the organization to follow the life cycle, then it really doesn't matter which one you pick. You're going to end up in chaos. Okay, very good. So I want to thank everybody for their excellent questions. Close this session out with a little bit more on our resources that we are available. The free webinars run once a month. Check our website, rbcs-us.com, to sign up. If you want a special webinar presentation for your company only of this webinar or any other topic related to software testing, send us an email, info@rbcs-us.com. If you missed part of this session, or you know somebody who could really benefit from this session, we will be running one at 8:30 p.m. Central Time, 6:30 p.m. Pacific Time. You can sign up for our newsletter at rbcs-us.com, which gives us discounts on consulting and training services, a regular newsletter with our featured article on testing and quality. You can follow us on Twitter. We are at RBCS. Been having quite a series of lively debates on Twitter lately, so check that out. We're also on Facebook, RBCS-INC. Do check your email over the next couple days. You might be the lucky winner of a free e-learning course. You were registered for a random drawing simply by attending this free event. You can check out my blog. That's rbcs-us.com/blog. Post comments or email me about topics you'd like to discuss. I've been a little backed up on the blog lately. Sorry about that. I've got a lot of writing contributions, but at some point I will start catching up. Check out the digital library, recordings of these webinars, along with podcasts and videos. You can subscribe to the podcasts on iTunes, enter RBCS Podcast into the search string. See the videos and recorded podcasts by subscribing to the recorded webinars, by subscribing to the RBCS channel on YouTube. We offer these free resources as a service to the software testing community, because at RBCS we are a not-just-for-profit company. This concludes the webinar. Thank you all for joining, and thank the people in the room for coming, and see you on subsequent webinars.